Okay. You know, today's lecture is on units. You know that.
Yes.
And tomorrow I will give you a separate lecture on. Okay, let me deliver the lecture on units, and later I will give you some concepts about pulleys, a little bit, not more.
Okay.
Okay. Now today's lecture is on units mostly. What do we mean by units?
What something is measured in, what quantity?
Yes. What we mean by units? You see, we have some fundamental quantities, as you know. We have some fundamental quantities, as you know, like you say, mass is a fundamental quantity. Then length is a fundamental quantity. Then we have temperature, time is a fundamental quantity. And then we have temperature, fundamental quantity. And then we have, you see, quantity of matter, quantity of matter. That's mole. And then we have current. And then we have luminous intensity, which is coming from light.
Okay.
When we receive light and we say that it has how many lumens we receive, how much luminous intensity we receive. So it is related to radiations, energy, radiant energy. Now all these physical quantities, you see, all these physical quantities, they need to be measured, isn't that?
Right.
All the physical quantities need to be measured because we define physical quantity as something that can be measured. And for measurement, for measuring these quantities, what we need? What do we need?
Unit.
Yes, we need many things. We need instrument.
Oh, right. Something to measure with.
We need instrument to measure the things, don't we? We have,
yes.
For length, we may have a rod. For time, we may have some measuring device. For temperature, we do need to have a measuring device. For current also, we need measuring devices for measuring these quantities, right?
Yes.
And at the same time, we need units. In those units, these quantities will be measured. For example, mass may be measured in kg, kilograms, right?
Yes.
And length can be measured in meters, right? And time is measured in seconds. Temperature is measured in Kelvin. Quantity of matter, okay, moles. And current is measured in amperes. And luminous intensity in candela. Candela, yes. Now, these are units, but in a very nice system, in SI system of units. Right? This is SI, Standard International System of Units. Mass in kilogram, length in meters, time in seconds, temperature in Kelvin, quantity of matter, and then we have current in amperes, then we have luminous intensity in candela. Right? These are called units. And the whole world has accepted this as a good system of units. That's why it's called Standard International. There may be local units also. In British system, they have poundals, pounds. They have feet as the unit for length.
Yes.
That is their own. That is their local system. We may have our local systems here in Kashmir and in other countries also. They have local units of measurement. Yes. But at the international level, these units are not understood. Suppose you have some unit at your local, in Pakistan, you may have some local unit, for example. Anybody else at some other part of the world, he may not understand that unit, what you are talking about. But kg, everybody understands because that has been agreed upon. Kg, meter, second. Now, I will not waste time to define what is kg. It is a ball and platinum ball and kept in some museum in Paris, and you compare every other mass with that to be 1 kg.
Oh, wow.
And
Oh, okay.
I will not waste time that there is a rod which is
Yeah.
called 1 meter and kept somewhere, and every other length is compared with that to have that meter length. No, it is.
Right.
These are well established units. We should not uh, go into that. Okay.
Yes.
Now there is one more system, that is CGS system of units. It is called MKS system. Sometimes this SI system of units is called also MKS system. That's meter, kg, second system, right? And this is centimeter, gram, second system. Time is the same in both the systems.
Right.
These two systems are still widely used, although this system is mostly used, but sometimes this system is also used, right? CGS system. And there's a relationship between this system and this system. That is simple. 1 kg of SI system, that is 10 raised to power 3 grams in CGS system.
Yes.
If this is 1 is small and kg is big, it is small into big is equal to big into small. Nay, you don't follow my point. It is small, but the unit is big. This is equal to something big into something small. If number is smaller, then unit is bigger. If number is bigger, unit is smaller. So that product is the same.
Yes.
It is something N1 U1 is equal to N2 U2. Numerical value and the units is equal to numerical value in another system into its unit. If this is small, this has to be big. If this is big, this has to be small. So that product is the same in both the systems, right?
Right.
So this formula will help us to convert one system of units into another system of units.
Yes.
And then you have, then you have relationship between meter and centimeter. That is 1 meter is equal to 100. That's 10 raised to power 2 centimeters, right?
Yes.
Or you can write 1 centimeter is equal to what?
1 out of 1.
Power, it will go there, 10 raised to power minus 2 meters.
5.
Yeah, 1 gram is equal to 10 raised to power minus 3 kg.
Yes.
You need to remember.
Yep.
Is that good?
Yes.
Cherry. Okay, that's so nice. Now, please tell me one more thing. How to develop units of derived physical quantities? Or these are the fundamental physical quantities of which I wrote the units. Fatma, is that right?
Yes.
But now I want to derive the units for derived quantities. Let me derive the units for fundamental quantities, for derived quantities. Is that right?
Yes. For derived quantities.
Derived quantities के लिए मैं units बनाना चाहता हूँ. So what is the procedure? How to deal with this? Let me start from a simple thing. I will start from a simple thing, and maybe I will go to the more complex derived quantities. But let me start with the simplest of all the physical quantities.
Yes.
First of all, you can't have a single set of units for the derived quantities. I mean, a physical quantity, you may say its unit is something A, and another person will say, no, its units are B. Some third person may say its units are C. All may be correct in their own ways. All may be correct.
Yes.
You understand my point?
There's multiple ways to.
Yes, there are multiple ways to express the units.
Okay.
So you can't say one system of units is better, or your units may be better than the units expressed by another person. Everybody is right in his own way. So you can't have a single set of units for a given physical quantity. Sometimes it may be expressed in different ways. Okay, let me start with number one. Let me start with, okay, velocity. In order to derive the, but possibly everybody knows it is meter per second, don't?
Yes.
Everybody knows it. Most of the students must know what is the unit for velocity. But let us see how it is derived. Maybe there are some cases where you have a physical quantity whose units you don't know. Whose unit you don't know directly, but you should be able to derive that, right?
Yes.
So what to do? The procedure is, the standard procedure is, write down the dimensions. Write down its dimensions.
Write down dimensions.
Yes. Write down its dimensional formula ही लिखो. Dimensional formula, right?
Yes.
From dimensional formula, one can write SI units or CGS units. Okay?
Yes.
One more procedure. Write down just formula. Write down the formula. And from formula, derive the units. Copy this rule. You have to copy this rule.
Yes, I wrote it down.
You wrote it down?
Yes.
You're so quick to write down things.
Yeah.
Okay. Okay. That is so nice. Now, let me go to velocity. Can you give me the dimensional formula for velocity? If you don't remember it, I remember it. LT minus 1.
Yes, LT minus 1.
And you know L is length.
L is length, so that's meters.
L is length, T is time. And in SI system, L you write meter, and T you write second, and inverse like this. Okay? So you just replace L by meter, T by second, or you can alternatively write it meter per second. Second you get down in the numerator, denominator. This is the unit. This is the unit, as you like it.
Yep.
Do you understand that?
Yes.
Okay, number second. Let me go to acceleration.
Okay.
That is, okay, dimension formula, LT minus 2.
Yes.
By now you should remember all these dimensional formulas, but if you don't remember, then you say how I write this. If you don't, so you should be able to write down the dimensional formula, right?
Yes.
So L is meter and T is second. Power is again minus 2. Can again write is meter per second square. You can write the unit for acceleration as meter second inverse 2 or meter per second square. Number third, momentum. Momentum is MLT minus 1. If you remember it.
MLT minus 1.
Now M is kg in SI system. Yes. L is meter in SI system, and it is S minus 1. If you ask me to write it as units in CGS system, then I should write for M grams.
Right.
For L, I should write centimeter.
Yep.
And for time, I should write the same as second, because in CGS system and the SI system, the time is measured in seconds, right? Okay. Now, it is a way to derive the units. Just write the dimensional formula, and from dimensional formula go to the units. Okay, fourth. Now, suppose I am talking of momentum. See here, you know, force is equal to change in momentum by time. Do you remember this formula? Yes. What about the change in momentum? Force into time.
Yes.
It is momentum, the same as momentum, dimensionally or units. Force is Newton.
Yes.
And time is second.
So Newton's.
So momentum is also expressed in Newton second. There's no problem with that. This is also the unit, and this also is the unit. But this, you can prefer this. This can be called as a fundamental unit. The momentum has fundamental units of this. A fundamental unit, you can call it.
Right.
This is not fundamental unit, but this is fundamental because momentum is put into fundamentals. MLT, it is put into fundamentals, and then you express it as unit. So it is called a fundamental unit. This may not be called as a fundamental unit, but both are units for momentum. Is it right? That's what I said. You have the two different sets of units for the same physical quantity, and both are right.
Right. Both express.
Okay.
Yes.
Okay. Now, fourth or fifth, possibly. Now, let me go to a simple thing, area.
Okay.
It is L2 is the dimensions and meter square.
Yep.
Sixth, your volume. That's L cube. That's meter cube. Units, they're units deriving from dimensions. Seventh, angular velocity.
Velocity.
What is angular velocity?
I don't remember its formula, the normal formula.
Okay, but it is angle divided by time.
Change in time.
This angle is radians. Time is second. So it is radian per second or a radian second inverse. That is the answer for angular velocity. If you remember the equation, you can just derive it, no problem. Eighth. Yeah, here I will tell you one more thing. Delta theta is dimensionless, isn't that?
Yes.
But it has units.
Mm-hmm.
So a dimensionless quantity, a dimensionless
quantity
may have units.
Mm-hmm.
We learned this from here because delta theta is dimensionless, but nevertheless delta theta has the units for radian. डायमेंशन तो है नहीं, लेकिन यूनिट तो है. तो इसीलिए मैंने कहा है डायमेंशनल क्वांटिटी हो उसको यूनिट हो सकते हैं, नहीं भी हो सकते हैं, हो भी सकते हैं. Is that right?
Yes.
Okay. Now let me go to seventh, eighth. Can you give me angular acceleration units?
Angular acceleration.
First of all, we must know it is formula, that is delta omega by delta t. Omega we got just change in angular velocity, that is radians per second. We got it just now in seventh by again time, that is second. That is radians per second square or radians second inverse 2. वो भी चलेगा. Ninth, Let me go to, okay, density. Simple. What is this dimensional formula? Mass
That's
m
mass of
ml minus 3. If you
M
remember, if you
minus
remember,
3. Yes.
if you remember it directly, if you want me to derive it, I will derive it. It's
No,
mass
I got
by volume. It is m by L cube. It is ml minus 3. Now, if you want to convert it into units in SI system, that's kg meter square, meter inverse 3. If in CGS system, what you write? Gram?
grams times centimeters inverse 3.
It is CGS system.
Right.
These are the examples that I give you how to derive units from dimensions. Is that right?
Yes.
Okay. Ninth. Current density. What is current density? Current into by area. That's current density, not volume. Because current is not concerned with the volume. It is only concerned with either with length or with area. So go, the current is ampere.
Yes.
This area is L square. That is AL minus 2 is the dimensional formula. So it is ampere and L is nothing but meter inverse 2. That is the answer.
Yes.
Magnetic field strength. B. How to derive its dimensions?
Is it the formula is just B?
Yes, can you write down the formula for B? Or I should tell you what is the formula for B.
Yes, please.
Should I?
Yes.
Okay. Magnetic field. You know magnetic field is B equal to mu 0 Ni. You remember that formula?
I know I haven't learned about magnetic fields.
Magnetic field inside the solenoid is this.
Okay.
Okay. You know F is equal to QV cross B.
Okay.
You know it?
Now I do.
Okay. You must be knowing any formula at least.
No, I'm just on level 1 right now.
Okay. Now, then you have okay, let me derive the magnetic field unit from this equation.
Okay.
I say directly, you can say magnetic field is Tesla. The unit for magnetic field is Tesla. But Tesla is not the basic unit. It is after a scientist's name.
Right. Just is not.
It's a Tesla. It's a scientist, name of a scientist. So one Tesla is what? So see here, F. Have a look. F is equal to QVB. This one. B cross B is VB. Now B is equal to F by QV. Right?
Yes.
So a unit can also be Newton per coulomb. Newton per?
Newton per coulomb.
Force is Newton.
Right.
Q is coulomb. And this velocity is meter per second. Here in the denominator. This becomes Newton. This will go up second per
second per coulomb meter.
Coulomb meter. Good. This second will go up to get multiplied to Newton, and this coulomb meter will remain in the denominator. This is the unit, and this is equal to 1 Tesla. Is that right?
Yes.
You can derive units from here, from this equation. That's all.
Yes.
From any equation you like, you can derive the dimensions. You can derive the units.
Yep.
It was which number?
11 now.
Huh?
Now we're on 11.
It was 11th.
This was 10.
10th. Okay. We are going for the 11th. Okay. Now 11th. 11th, let me go to luminous intensity.
Okay.
Luminous intensity of illumination. What's that?
Of illumination.
It is unit is candela per meter square. How much light you are receiving per meter square per unit area? So it is candela meter inverse 2. Just remember it. 12th.
Right.
Okay, let me go to moment of inertia. You know its dimensional formula? Okay, I will tell you. ML2. If you remember mr square, moment of inertia mr square.
Okay.
And then m is m and r square is l square because r is radius. It is kg, m for kg, and what about l? Meters. And square of it. This is the unit for moment of inertia. 13th. Can you give me the unit for radius of gyration?
Radius of gravitation?
Gyration, G-Y-R-A-T-I. It is simply length.
Okay.
Radius of gyration is nothing but length.
Okay.
And this is just a meter.
Right.
Now let me go to 14th. 14th is linear expansion, coefficient of linear expansion.
Linear expansion.
Coefficient of linear expansion.
Right.
Or area expansion. That's also called as area expansion.
Area expansion.
That's also called as superficial expansion. Okay.
Okay. Superficial expansion.
Or even volume expansion.
Oh wow. Volume expansion.
This is written as alpha, and this superficial expansion or linear expansion is written as beta, and this volume expansion sometimes written as gamma. Coefficient of linear expansion you call it, coefficient of superficial expansion you call it, coefficient of volume expansion you call it. Okay, that's right. And you know, if you heat a wire, one dimensional wire, it will expand this linear expansion. If you heat a plate having some area, it goes for superficial expansion. If you heat water or a solid ball having some volume, it will expand, and that has a volume expansion. And all the three, interestingly, have the units of K inverse, Kelvin inverse. Will you remember this now?
Yes.
Because you see, okay, I will. Which one should I derive? This one, or this one?
Alpha.
Alpha, okay. Alpha is defined change in length. If it's a wire, You heat it, it changes, it expands. Change in length, whatever expansion is there, by original length into temperature rise. This change in length is the same as length dimensionally. That is L. This here is also L. Change in length will be again a meter. It will be a length dimension, right?
Yes.
Maybe change in length will be again in a meter. It will not be something like seconds. It will be meters. And
Right.
this is delta T. This is not time. This is temperature. This cancels and is K inverse.
Got it.
And gamma is change in volume by original volume into delta T again. So this volume and volume has the same name. They cancel off. Again, it is K inverse. So all the expansions, maybe alpha, maybe beta, maybe gamma, have the same units as K raised to power minus 1. Do you follow that?
Yes.
You must. Okay. Now, 15th. 15th. Okay. Flow rate. You know, flow rate means water flows through a pipe per second. Some kind of oil flows through a pipe. How much oil flows through a pipe in 1 second?
Right.
What are its units? You know, flow rate is nothing but flow. When we say flow, it is volume. Flow rate means how much volume over time. How much water flows, how much volume of water flows in per unit time. That is LQ by T. That is meter cube by second. This is the unit. How much volume of fluid flows per second, cubic meter per second, or cubic meter second inverse. This is the unit for what you call as flow rate.
Okay.
Can you remember this?
Yes.
16th. Now, let me go to frequency.
Okay.
Frequency, you must know, it is 1 by time period.
Okay.
T minus 1. That is second inverse. That is the unit for frequency, second inverse. And here's a name for it. There's a second inverse has got a name. That is hertz. What's it?
Hertz.
Hertz. That is hertz. Okay. That is right. Okay. But this is not the basic unit is this. This is after a scientist's name in his honor, right? 17th. Force. Unit. The dimensions. M, L, T minus 2.
Yes.
Convert this into units.
MLT minus 2
kg,
equals
meter, second
kg.
inverse 2. Isn't that?
Yes.
And that is called after the scientist Newton. This is the fundamental unit, I mean in basic parameters, and this is after the name of a scientist. If somebody says what is 1 Newton equal to, say it is 1 kg meter second inverse 2. That should be your answer.
Got it.
Is that okay?
Yes.
Which one? 18th.
18.
Okay. Now, what about energy? What's the unit of energy? Okay, energy. Heat, work, chemical energy,
Yes.
etc. Maybe many other forms of energies. They are the same units. What? It is ml2t minus 2 is the dimensional formula, and unit should be, okay, kg in SI. I just write every time SI system. I think CGS system you can write yourself, right?
Yes. Yes.
L is meter square and S minus 2. Somebody call, you see, it is the basic. But in honor of a scientist, it is called as 1 joule, because joule is the name of a scientist, right?
Yeah.
19th. Now, what about pressure? Pressure or citrus, same. It is, unit is what? Okay, put it into dimensions. Pressure or citrus, the same thing. It is, what's that?
Pressure and stress.
Pressure M, L minus 1, T minus 2. If you remember it, good. If you don't remember it, then it is your job to get it back, get back to your material, steady material, and try to know it.
Right.
Okay, kg meter inverse second inverse 2. And if you convert this, you see, yes, that's right. This is the unit for pressure or citrus. It can be after a name of a scientist, Pascal, called Pascal.
Yes.
Pascal was a scientist, right? Okay, let me give you one more unit for pressure. Let me see if you can appreciate that. Pressure is force per unit area by definition.
Right.
And this force is nothing but Newton. And area is nothing but meter square. So it is Newton per meter square also is the unit for pressure or this citrus.
Yep.
You can do it with this, you can do it with this, you can do it with this. This and this are both are the units.
Yes.
Okay, 20th. Quantity of electricity. That is charge. What are its units?
Charge.
Charge is, okay, current into time. Current into time. And our current, that is ampere, and T is second. Ampere second is the unit for charge. And in an honor of a scientist, you can call it coulomb.
Right.
Actually, it's ampere second, but you can call it coulomb.
Yes.
'21. Don't forget that what I am doing. I am trying to convert dimensions into units. And mostly I am converting into SI system of units. I think if you want to convert it into CGS system of units, that's also easy for you. Okay, let me go to power. Can you tell me what is the dimensional formula for power?
Power.
Work done per unit time.
Work over time.
L2T minus 2 by T. That is ML2T minus 3. Convert it into units. That is kg meter square second inverse 3, right?
Yes.
And sometimes people like to call this unit, whole unit, as what? Scientists need to be honored, right?
Yes.
And they go in history like this, because every time everybody has to write the power equation, he has to write watt. So what comes to one's mind? That he was a scientist. He did a lot of work in the field of this electricity and power and current. Now 22. Can you give me the units for electric potential?
Electric potential. Can you give me just the formula?
Electric potential or electromotive force, that is the same thing.
Okay.
What should I do? Electromotive force. First of all, can you give me the dimensional formula for electric potential?
If I'm given the original formula, then I can get the definition.
That is right. But why should I give you the formula?
Because I don't know this one.
Why should I? It is work done per unit charge. And work is nothing but ml2 t minus 2. Charge is current into time. And I will get it ml2 t minus 3 because it will go up to become minus here, power. And current is ampere minus 1. Right? So why not convert this into units?
Yes.
That is kg. Yes. Meters square.
Third, second, inverse 3.
Yes. And ampere minus 1. That is the answer.
Yes.
And sometimes maybe this is called volt. Again, after a scientist's name. But this is the basic unit. Okay. Now let me go to one more example, 23rd. Do you understand how I do these things?
Oh, yes, yes, I know that.
That's good. '23. Can you tell me what is the dimensional formula for what you call as magnetic moment?
Magnetic moment.
First, I must tell you magnetic moment. What's the magnetic moment? How can I write the magnetic moment formula? You see, if you remember, potential energy is equal to minus m dot b. If you remember this equation is in the magnetic fields. When a magnetic dipole is placed in the magnetic field, it has a potential energy. It has a potential energy. This is potential energy. This is magnetic moment. This is magnetic field. So it is potential energy. This is magnetic moment. This is magnetic field. Right?
Yes.
Okay. Now you can write U is equal to minus mb. So what is m? Magnetic moment. That is U by b. Isn't that?
Yes.
This and b will go down. Okay, with a negative sign, doesn't matter. We have to find the units. We are not bothering about this negative sign. So what is potential energy unit? Joule.
Joules.
And what about magnetic field? Tesla.
Tesla.
So it is Joule per Tesla. That is the answer.
Okay.
You start with this equation, go to this, get rid of this dot and mb, because we are finding the units. We don't need to write what is the angle between m and b and then write cos theta. No. So m is U by b and is Joule by Tesla. It is Joule. That's the answer, right? It can be, you can substitute for energy ml2 t minus 2, then Tesla, it is formula. Then you can derive one more set of units, isn't that?
Yes.
You can derive one more set of units.
Yes.
Now, what about, which one is this? 20?
23.
23. Are you sure?
Yes. Or this one is 24. Is this new one?
Yeah, 24. Dipole moment.
Dipole moment.
Electric dipole moment. You know, it is a definition. You see positive charge and then there is a negative charge, Q, it is minus Q, it is L, and dipole moment, that's P, is defined as charge, one of the two charges, that's Q, into length.
Right.
If you remember it properly. I don't know how much knowledge you have about these things. It is, Q is charge, that's coulomb.
Yes.
And L is length, that is meter.
Right.
Coulomb meter answer. That's the unit for dipole moment. Coulomb meter. 25. Power density. Power density is Power density.
Yes.
That is,
So power.
per unit volume.
Right.
When there's a density you talk of, you have to divide by volume. So it is watt by meter cube. That is watt meter inverse 3. So sometimes you may be given this what you call as imaginary quantity. It may not be in real physics. It may not be a real physical quantity. Power density may not be a real physical quantity, but sometimes they may ask you, what is power density? You understand that?
Yes. Yes.
So they may ask you such a question. Okay. Power density, you can just write, you see, watt per meter square. It is obviously it is hypothetical quantity. It may not exist in the real world. This quantity may not exist in the real world. It may be a hypothetical quantity, but you may be asked to find just units hypothetically. Anyway, okay, that's all. That's all. And you search for other quantities. Maybe you find new physical quantities, and you need to find their dimensions and units. You do it yourself, right?
Yes.
You may do it yourself. Now let me go to one more concept, a new concept, a new concept, how to convert one system of units, conversion of one system of units into another system, right?
Yes.
Conversion of one system of units into another system. It is a very important concept. You have to learn it. I will try to explain this. See here. The rule is, you see, don't you know 1 kg is equal to 10 raised to power 3 grams?
Grams.
Okay. But what system is this? SI system.
Yes.
And what system is this?
CGS.
Good, that's right. Now, in SI system,
Yes.
you have this numerical value, and this is the unit. This is in CGS system, this is the numerical value, and this is the unit. Say kg is larger quantity, larger unit, but numerical value is small. And here gram is a small unit, but numerical value is larger.
Yeah.
You understand my point? So we have, because they are equal, this is equal to this. So numerical value should be, that is n1, it is u1 is equal to n2 u2. In a system where unit is lesser, unit is higher, n1 is lower. In a system where unit is lower, numerical value is higher. So that product is the same here and here. That is all. This you have to remember. And this is the rule by which we can convert one system into another system. Now see.
Yeah.
Now see. Now, suppose question is like this. Convert 1 Pascal, that's pressure in SI system, into CGS system. That is 1 Pascal is equal to how many times the CGS units?
Right.
Let me solve this problem. Have a look. First of all, you see pressure. Pascal is pressure. So what's pressure dimensions?
Pressure
M L minus 1 T minus 2, right?
Yes.
Do you understand this?
Yes.
Okay, now see, very interesting. I will write like this. N1 U1 is equal to N2 U2. This is SI system. This is CGS system, right? N1 is numerical value in SI system. N2 is numerical value in CGS system. See here, what's N1 in SI system?
1.
1. What is U1 in SI system? Okay, right, L minus 1, T minus 2 first. This is in what system?
This is SI system.
Good. N2 you don't know. This we don't know.
Right.
This is M2 is here. Okay. What is U2?
U2 is gonna be
M L minus 1 T
minus 2.
Magar, this is SI. This is what?
CGS.
Good. You just write N1 U1 is equal to N2 U2. N1 you know it is 1.
Right.
N2 you don't know. But this is ML minus 1 T minus 2 SI system. It is ML1 T minus 2 CGS system. Okay? Now see what I will do here. There may be other ways, but this way you have less chance of committing an error. Have a look. This is 1. What is M in SI system? kg.
kg.
What is L in SI system? Meter. Inverse 1.
A time second.
It is right.
Yes.
It is N2. What is M in CGS system? Gram.
Grams.
What is L in CGS system? Centimeter. Inverse. What is time in CGS system?
Seconds.
Okay. What is N2 that you have to find? Number in the CGS system. That's 1 kg. Meter inverse. Second inverse. Divide by gram. Centimeter inverse. Is that right? Now what's kg? That's 10 raised to power 3 grams. This one. What is meter? 10 raised to power 2 centimeter. Whole raised to minus 1. Second inverse. Whole divided by gram.
Centimeter inverse.
Is that right?
Yes.
Okay. Okay. See here. 10 raised to power 3 gram. 10 raised to power 2 whole raised to minus 1. How much is that?
10 centimeter. 10.
10 raised to power 2 whole raised to minus 1. How much is that?
Minus 2 centimeter.
Good. Centimeter whole raised to power?
Minus 1.
Gram. Centimeter inverse. Second inverse. Is that right?
Yes.
Goes off. Goes off. Goes off. It is 10.
Times.
10 is power minus 3. 10 is power minus 10.
10 to the first.
It is 3. It is minus 2. 10 is power 3 minus 2 is 10 is power 1. That's 10.
Yes.
So 1 Pascal is equal to 10 CGS units of pressure. That is the answer. No, you don't follow me?
No, I follow.
Okay, I will give you one more example. Let me give you one more example. Convert 1 Newton into dynes. Dynes is a CGS unit. First, it is force. Write down the dimensional formula for force. mLT minus 2, right? N1U1 is equal to N2U2. What's N1?
1.
1, good. What is U1? mLT minus 2. Okay, invert SI system is equal to its N2. What is U2? The same T minus 2 CGS. So what is N2?
2 is
1
1
into
times
mLT minus 2 SI divided by
divided by
mLT minus 2 CG. Okay, let's see what I will do. I will do. N2 is equal to, it is, what is this M? kg. What is this L?
Meters.
What is this second?
Second minus
What is this M?
grams. Centimeters. And then seconds.
And S minus 2, right? So see here, this kg is how many grams? 10 raised to the power 3 grams.
Yes.
This meter?
Centimeters squared. 10 squared.
10 raised to the power 2 centimeters, right?
Yes.
Divide by what? Gram?
Grams, centimeters.
10 raised to the power 5? Right?
Yes.
As 1 Newton is equal to 10 raised to the power 5 dynes. So we were N1U1 is equal to N2U2. Your 1U1 is equal to 10 raised to the power 5U2. This is Newton, this is dyne. So 1 Newton is equal to 10 raised to the power 5 dynes. Should I give one more example?
Sure.
Okay, okay, no problem. Now, convert 1 joule into ergs. Ergs is CGS system. Joule is SI system. So first of all, energy, that is joule, that's mL2T minus 2 dimensional formula. That's N1U1 is equal to N2U2, right? This is N1 is 1 joule. Okay, 1. What's U1? mL2T minus 2. It is N2 is, okay, that I have to find. What about U2? mL2T minus 2, but it is CGS, this unit. And this is SI. Now it is 1. Substitute it here. It's kg, meters square, second inverse 2. It is N2. It is gram, centimeter square, second inverse 2. What is N2?
1 kg meters squared centimeters.
Just a minute. Just a minute. N2 is equal to kg meter square, second inverse 2. Second inverse 2 whole divided by
grams, centimeters squared.
gram, centimeter square, second inverse. So let me substitute. Kg is equal to 10 raised to the power 3 grams.
Yes.
Meter is equal to 10 raised to the power 2 centimeters. But it is meter. It is meter. It has a square. It is square of it. This square is of the meter, but meter itself is 10 raised to the power 2 centimeters. Divide by gram, centimeter square, second inverse 2. That is 10 raised to the power 3 grams, 10 raised to the power 4 centimeters square, it will get multiplied, centimeter will get squared, minus 2. So what about the denominator? Rem centimeter squared second inverse. Cancels, it always cancels. 10 raised to power 7. So 1 joule is equal to 10 raised to power 7 ergs. You please try to understand this concept and try it this way, because this way the error possibility is very less. There may be formulas, direct formulas, which you can use, but there one can commit an error. So this is all for today. I must stop now meeting. Good luck. And you try to concentrate on this, and tomorrow I will upload the assignment on my website. That is, the website is Tantray sir.
Okay.
The website name is this, Tantray sir. .com. Okay.
All right.
Let me stop.